All right, good morning, good afternoon, or good evening, students. This is our 5th video for this chapter, and it probably won't be the last. But it's quality and quantity all at the same time. No sacrifices here. So, our last video covered slides 16 through 22. This is our most recent one. I added it 4 hours ago, if you're living in the present. Now, the next video goes to slides 23 and starts there. As always, let's remind ourselves why we're even doing this. We want to understand problem 1, how does our environment influence survival? And we want to understand problem 2, which is what do we need to know about our environment? What's important to us? What do we need to know? And we have been covering some of these vocabulary ideas, but soon we're going to start talking more about succession and what that means, about our survival, and what climate change means for our survival. And of course, we'll constantly remember that we are doing an ecolicious experiment to better understand problem 2. And we also want to know if there's some climate change issues happening in Burbank or California or our planet, okay? So we're going to study this continually. But these are both the 2 reasons why we're doing everything we're doing in this chapter, Ecology. Work with what you got. All right, let's move forward. Slide 24. So in your notebook, please write slide 24 and copy the definition. Now, last video on slide 22, we learned that primary succession is new life forming where it had never been. That's primary. Secondary is the new wave, and on slide 24, the definition says it's an environmental change that takes place after a natural disaster or human cause. In other words, it's succession or a change to the environment where life already existed. Most succession is secondary. It's when the environment changes. So succession generally is secondary succession because most places have living things, and where they live, the environment changes. Let's look at some examples. In our picture on the slide, we have a fire that occurs in an area, and you can see slowly over time, over years, it says 1 to 2 years, 3 to 4, 5, and 150, eventually the forest is expected to regrow eventually. So the populations of certain species increase over time, over 150 years, to a forest once again. Another example of succession could be, according to this little graphic, that certain areas of North America and our country, the US, are slowly increasing our winters. So our winters are warming or increasing in temperature gradually. So that's another form of succession, would be climate. We have this video as well. They're focusing on Vegas, and Vegas is experiencing succession. Succession as in the city growing over years. So let's watch this. It says 1999. Let's see if you can see the succession. The city is clearly growing and changing the environment. So as the people live in the city and as the city grows, the environment is changing. The land is changing. Succession is occurring, secondary succession. Here's another example. This is South America, and the darker greens are lush, unchanged rainforest. And these are satellite images, like we were just watching for Vegas. So we're in South America now. The lighter colors is succession. Anywhere where you see lighter colors, it's where the rainforest is being changed. It's being logged, and the forest is being cut down. So over time, from 2001 to when this ends, you're seeing increased areas of succession or secondary succession where the forests are being cut down for logging or mining. So the environment is changing, and it's human-caused changes here, the deforestation. Logging and mining to get resources for human use. All right, welcome to slide 25. On slide 25, it's our introduction to hell. But don't be scared, this is a good hell, not that bad one. Hell represents how we use hypothesis, evidence, and how we link evidence and hypothesis together. So it's getting us ready to do a new activity in our class called Hell, and it's going to be based on secondary succession. So in your notebook, please write slide 25, and then copy down this definition of secondary succession. It says climate change. And it also, this definition indicates how we will use HEL or HEL to learn about this secondary succession, climate change. It says HEL is a way for us to study secondary succession in climate change. Perfect. It also says that HEL is using hypothesis, evidence, and making arguments. And it also says that we will use the HEL worksheet each week until we can argue with evidence about climate change, a form of secondary succession. Here's a little screenshot of what our form looks like, the HEL worksheet. And we will be learning in class how to use it. So for now, we're just going to write things about HEL, but we won't use it until we're in class. But it's about climate change. So we're going to be using the HEL activity to study climate change, a form of secondary succession. Here's a bigger view of the form. So in class, we are going to have two hypotheses. And each week, or a couple times a week, we're going to add new evidences in here that will either support or go against these hypotheses. That is, climate change is a threat to all organisms, or climate change isn't a threat to all organisms. So we'll slowly be looking at evidence while doing this HEL activity. And then it has a back page too, where you can see we'll draw arrows to indicate if an evidence supports or goes against these hypotheses. And we'll also fill out the back of the worksheet, which explains how a specific evidence strongly supports or contradicts, goes against a specific hypothesis. All right, if we're going to be talking about climate change as a form of secondary succession, we definitely need to start thinking about what climate is. Let's first define climate before we try to argue about climate change. So first, in your notebook, please write slide 30 and then copy down this definition of climate. It says climate is rain, wind, sunlight, temperature. It's more than that, but let's just keep it simple. That determines where biomes, we don't know what that is yet, it's okay, we'll learn soon, form on the planet. So basically climate, rain, wind, sunlight, temperature, determines what environments are like. Abiotic variables, right? So climate includes rain, wind, sunlight, and temperature. All right, next thing is, in your notebook for slide 30, I want you to predict if these four variables are in low amounts or high amounts for each region. So in your notebook, you'd write 1, rainforest, and then under that, you would put rain, wind, sunlight, temperature, and you decide, do you think rain, is there a lot? So I would just, let's assume we all agree that rainforest gets high amounts of rain. But what do you think about the rainforest getting wind? Now there's lots of trees, and trees block wind, so I'm going to put low levels of wind. I could be wrong, but again, I'm just making a hypothesis and making an educated guess. Sunlight, I'm going to say that they get high levels of sunlight. The temperature, because they get all that sunlight, I'm going to say they have high temperatures. Because I have been told that the rainforest has warm temperatures, lots of sunlight for plants and vegetation to grow. I'm thinking it has low levels of wind because there's so many trees it probably blocks the wind. And I think they get lots of rain. So high temperatures, lots of sun, and lots of rain. Sounds like a perfect recipe, a perfect climate for plants to grow. Now on you, I want you to do this on your own. So for slide 30, you would write 2, grassland. And you say, what do you think would be the case for these ones? Do you think it would be high levels of rain or low? Just based on the picture. So look at the picture of a grassland and decide, do they get lots? Do they get low or high levels of rain? Do you think it's low or high levels of wind? Low or high levels of sunlight? And low or high levels temperature? So based on this picture, what do you think? It's low or high levels for each of these abiotic variables that determine the climate of grassland. All right, if we're talking about climate, we're talking about Earth, and we're talking about large areas on Earth that have common amounts of rain, wind, sunlight, and temperature. When we study the Earth and we study areas of Earth, big parts of Earth, we find out that certain amounts of rain or certain temperatures are related to latitude. And latitude are these yellow lines here. Now they're imaginary lines, don't expect to really see these anywhere. But the equator is 0 degrees latitude, and as you go north of the equator, the numbers in latitude increase as you go north all the way up to 90. And then if you go south of the equator, the numbers also increase, but to the south pole, right? Now, each of these lines has characteristic climate, certain temperatures and amounts of rain, amounts of sunlight. So let's start out with, in your notebook, write slide 31, and let's copy the definition for latitude. It's imaginary lines, not real. We use it to map the Earth, but they're not really there, of Earth, and it says biomes are found only at specific latitudes. So there's that word biomes again. We haven't learned what biomes are. That'll come, don't worry. But biomes sound like they're certain areas at certain latitudes, and they have a certain climate, okay? So we're learning, so there's something about the environment. We find them at latitudes, specific latitudes. And then it says climate and latitude are related. So there's a connection. So that's basically saying at 0 degrees latitude, there's a specific climate. And at 30 degrees latitude, there's a specific climate. And 60 degrees latitude, there's a specific climate. Generally, people have learned or heard that the equator is kind of warm, like tropical. And then you have really high areas like 90 degrees north or south tend to be really cold. So let's do some questions for slide 31 so that we can practice this idea of latitude. It says question number 1 for slide 31. So in your notebook, write number 1. It says estimate number of degrees from Cali to the equator. So it says estimate, so we don't know exactly, but I'm looking here, and this is kind of California, so I'm going to say 30 degrees to the equator. So if we went from 30 degrees latitude and we headed south to the equator, and it's 0, 30 to 0, we would travel how many degrees? Well, we would travel 30, because 0 to 30 or 30 to 0 is 30. So it'd be 30 here, then we've traveled 15 degrees latitude here, and to get to the equator we travel 15 more. So every line basically jumps 15. So it's 15 to here, and then 15 to the equator, so it's a total of 30 degrees we traveled. Number 2, it says estimate number of degrees from central Mexico to Europe. So Europe's up here, and this is central Mexico. So if this line is 0 and this line is 30, the middle must be 15. So we do 15, and we're traveling up to Europe. So so if we go from here to here, we've traveled 15 degrees. If we go on another line, we've traveled 30. So you could say 30 to 45 degrees traveling from here to get up to the latitude where Europe is, okay? And then number 3, it says hypothesize how climate may change from Mexico to Canada. So if you go from 15 degrees latitude all the way up to here, higher up, do you think it's cooler or warmer as you travel up? So if you go from Mexico here, 15 degrees latitude, up to 60 degrees latitude, do you think the climate is going to get colder or warmer? So is temperature going to drop or temperature going to go up? Do you think there will be more rain or less rain? So what are things about climate? So just describe what you think would happen with the rain, wind, sunlight, and temperature as you go from 15 degrees latitude up to 60 degrees latitude where Canada is. All right, next slide is 32. 32 does not have a definition, but it does ask us to think about how sunlight from the sun hits the surface of Earth. And sunlight hits Earth with different force. Just like you have a punch from a boxer, sometimes it doesn't land perfectly. Sometimes it's not as powerful when the punch hits the head, right? And sometimes you have a good solid jab and it hits the face with a lot of force. We want to think about sunlight hitting the Earth in different ways too, because depending on how light hits the Earth, we see more heat or less heat in the climate. So the temperature, based on how light hits the surface, we get lower temperatures or higher temperatures, just like when a punch lands really well, it's more intense than if it doesn't hit the mark perfectly.